that's 12 point. That so that is for that. That's for that. Do you understand that that will be still what electron volt. So that is for that. I hope you understand. That's two important key things there. That is, when you have the highest change in energy level, produce highest frequency. Then when you have the smallest change in energy level, then it will produce the lowest wavelength. Is that okay? So that's for that. Now let me go to another question there, number 3. Let me go to that number 3. Number 3 is, I think that is still a diagram. Number 3 will still be a diagram. Number 3 will still be yeah. Let's see this question. This number 3, we solve the number 2, then number 3. That's the diagram for number 3. Then you can write question under that number 3. The diagram above shows energy levels in the mercury atom, where level 1 is the ground state. Can you see which energy change represent the ionization of the atom? Represent the ionization of the atom. Now let's look at the diagram. This is the diagram. This is the diagram. That's the diagram of the world. Now you can see the transition. We have a transition from, because they call this, you have to understand this. This is your energy level 1 is your what? Is your ground state. If you know that, that's the first thing you need to discover, is the ground state. So that's why I try to explain the energy level diagram to you. Now, electron move, that's transition occur from the ground state to the first excitation state. I get it now. Don't mind them because they call this one, but it make you to realize that is the ground state. I get it now. You're still looking at this as the ground state. That means these two, I get it now, will be the first excitation state. 3 will be the second excitation state. 4 will be the fourth excitation state. Then you have 0 electron volts here. I get it now. They are now asking you the question that where is the question? Which energy change represent the ionization of the atom? If you look at the definition of ionization, I've told you that when you have an electron, now look at this, is from here to here. This is from here to here. I get it now. When electron move from the ground state, I get it now, to this infinity, because this is 0 electron volt. I get it now. That is, this will be the what? The ionization energy. I get it now, because you can see this to this can still come back, this can to this, but this is going to this. This may not be able to return back to the ground state. Do you understand that? So when you're talking about that means this B, from energy level, that should be, it moved from energy level minus 10 electron volt to 0 electron volt. Take note of that. Once an electron move from the ground state to 0 or above 0, that is what we call the ionization of the atom. That is when the atom has been ionized. Is that taken? So let's move to that number 4. This is the diagram to the number 4. You can put it down, then look at the question under that. They said in the diagram above, an electron falls from energy level 3 to level 2, energy level 3 to level 2. I know you should have energy level 3 to level 2. They said in the diagram above, an electron falls from energy level 3 to level 2, full stop. It then emits a photon of wavelength. It emits a photon of wavelength 6.875 multiplied by 10 raised to the minus 7 meter. Roman go on there. Calculate the energy change in EV. Then the second Roman go to calculate the energy level. Okay, calculate the energy level 2 in EV, that is in electron volts. So let's see that question together. Sorry, it's hot for me. So let's quickly see it. Now, okay, I don't need this again. I can about this. Dealt with this. So let's see that number 4. Let's try to solve it. Now, the question is telling us that you do at what? That in the diagram above, an electron fall from energy level 3 to level 2. It then emits a photon of wavelength. The wavelength is given in that question. Wavelength emit is what? Is 6.875 times what? Times 10 raised to minus what? Minus 7 meter. What other parameters given? Then I should calculate the energy change in electron volts. I want to calculate the energy change here in electron volt. What will come to your mind first is your what? Change in energy should now be equal to your what? HF, which is also equal to what? HC over what? Over lambda. Is that taken? You can see from that question, frequency is not given, but what? But the lambda, which is the wavelength, is given. Therefore, I can have my change in energy to be equal to what? HC over lambda. Let me see whether whether this is given. Okay, it's not given, but I think we have been talking about that. We can take our Planck constant. Let's take our Planck constant at 6.626. I mean, let's take my Planck constant. Let me put that one here. Okay. Before that, let me even put the parameters there. Sorry, let me put H. Let me put the Planck constant H to be 6.626. I mean, multiplied by what? 10 raised to power minus 34 joule seconds. Then I think speed of light, the speed of light to be what? 3.0 multiplied by what? 10 raised to power 8 meter. Let's take that. Let's take that. So if I can now imply that what? That my change in energy level should now be equal to what? HF, which is still the same thing as HC over what? Over lambda. So I need my change in energy to be equal to what? HC over what? Over lambda. Now, what am I going to do now? We are talking about moving from 3 to 2. Mind you, when you are talking about changing energy, whether it's moving from up to down or if moving from down to up, it's still the upper energy level minus the lower energy level. So changing here now, that will now be what? It should just be what? E3 minus E1 to be equal to what? HC over lambda. And E3 is what? Minus 3.7. Then minus E2 will now be what? Okay, they ask us to calculate there. What they want me to calculate, sorry, they said in the diagram above, an electron fall from energy level 3 to this. They are now asking me calculate the energy change. That means I don't need to change this because I don't know this. So calculate the energy change. So that's changing energy. That's what I mean. That means changing E. So if I want to calculate changing E, then Planck constant is still what? 6.626 multiplied by what? 10 raised to power minus 34. Then speed of light, that will be 3 multiplied by what? 10 raised to power 8. Then the lambda is also given as 6.875 multiplied by what? 10 raised to power minus 7. Can you see that now? So let me input it in my machine. Then we have this. That means I will have 6.626 multiplied by 3. That will be what? 19. That will be 19.878 multiplied by, that will be 10 raised to power minus 34. That will be 34 minus 8. Our is very, very large, but I will see what to do in order to get it across to you. So you have to work on this. I'm very, very tired now, so I will leave now. But thank you. I see you by next class.